And just say, so James Bourne, Home Counties North East Chair, and today we've got an interesting presentation on wastewater heat recovery. Interesting subjects. I don't know a great deal about it myself, must admit. And we've got Joe Short and Stuart McDonald from Recirc Energy, who are going to talk to us for about 30 minutes or so, and then there'll be plenty of time for Q&A. As usual in these formats, you're all on mute, your cameras don't work, but the chat box does. And between Stuart and Joe, they'll manage some Q&A sessions towards the end of the presentation. So before I hand over to them, just a note for everybody is it's coming up to that time of year where CIBSE AGMs are happening. So please have a look out for the notice. It's going to have the nominations for the next year for CIBSE Home Counties North East. And I paused then and I just remembered, because I think we're doing this one, we're doing actually in partnership. So the adverts have gone out as well to our colleagues in CIBSE East Anglia as well. So good afternoon to any colleagues from CIBSE East Anglia too. The numbers are creeping up, but it is 3 minutes past. So for those of us that are here, I'm just going to hand over now to Joe Short and Stuart McDonald from Recirc Energy to talk about wastewater heat recovery. Off you go, guys.
Great. Thanks very much, James. And thank you, everyone, for your time this afternoon. We are going to take you on something of a whistle-stop tour of wastewater heat recovery and its current deployment in the UK, the position of the technology. Hopefully, at the end of the presentation, you might have some ideas about where the technology may fit with schemes and projects that you're looking at yourselves. There are a number of subject areas that we'll cover in the presentation. We would like very much for you to present questions via the chat box, and we'll manage those. As James has said, presentation will be about half an hour. We're leaving lots of time for questions. We find that typically there are lots of very good questions, and we can delve into any of those subject areas much deeper if that suits. Obviously we'll leave some contact details up at the very end of the presentation. If there is anything you'd like to pursue any further, then feel free to contact us. So who are Recirc Energy? Well, if we could have the next slide, please, Joe. Recirc is a niche energy consultancy specialising in wastewater heat recovery. We work predominantly with municipal wastewater, but we also look at trade effluents and heat recovery from trade effluents as well. We own and operate the first commercial heat from sewer project at Borders College in Galashiels. That scheme has been in operation since 2015. It is comfortably now delivering approximately a gigawatt hour of heat a year to the college under heat supply agreement, and it has been the proud recipient of 2 awards for innovation. One was a Green Gown Award for innovation, and one was a Scottish Renewables Award for innovation. We are the only UK wastewater heat recovery who are fully technology agnostic. So we work with a number of leading technologies in this space, and there are proprietary technologies, and there are also systems configured with off-the-shelf componentry configured in an innovative way. So we work with all the leading manufacturers, and we also configure systems of our own right as well. There are, for those of you who are not aware of the position of schemes in the UK, there are 3 operational schemes in Scotland. There are a number at the sort of feasibility and beyond stage in England and the rest of the UK. But Scotland appears to have blazed something of a trail here, having had 3 projects in the ground, one of which, of course, is Borders College. There's another scheme on a wastewater treatment plant in Stirling, and a 3rd scheme in Campbelltown in Argyll and Bute, which is we'll talk a little bit more detail about as the presentation goes on. We are also involved at the moment with a number of water authorities. So there are a key stakeholder in these schemes is the water authorities. So we're advising and working with a number of water authorities around the deployment of the technology from a technical and commercial basis. That's a little bit about us, and I'll pass over to Joe Short now to pick up on what the basics of the system are. Thanks, Joe.
Thanks, Stuart. Hi, everyone. I'm going to go through quite a few slides quite quickly, but don't worry, you will get a copy of the slides after the session, so don't worry about that. And yeah, if there's anything that I rush over a bit quickly, there is a Q&A session at the end, but also we will give contact details at the ends of the slides. So if you do want to contact us after the session about anything specific, we're more than happy to receive any queries and questions after the presentation. So yeah, if I get straight into it, what we're talking about, but essentially what we're talking about are water-to-water heat pumps, but rather than using rivers, groundwater, etc. as the heat source, we're using wastewater, and obviously that requires a certain amount of unique pre-treatment before it can be put into a heat exchanger, or in some cases directly into a heat pump evaporator. So we're going to go through some of the technology, some of the configurations, some of the potential applications of the technology. So one of the first things I'd like to point out is that, and this has been done mainly in North America, it is possible to take the wastewater from a building itself, particularly if it's large enough, so it's producing a significant amount of water, and we can extract the heat from that. It's nice and warm as it's come straight from the building and not from the sewer in the ground, and it is possible in most cases to recover around 50% of the domestic hot water demand just from what the building produces itself. Obviously a much smaller fraction of the space heating demand. A couple of little rules of thumb there, that you could get somewhere akin to 40 kilowatts of heat production out of 1 litre per second using that technology, and the systems can range anywhere from 20 to 250 kilowatts or even higher. Here's a couple of examples of the technology. Piranha on the right, made by a company called Shark Energy, an all-in-one system with a heat pump built in, and a technology on the left there, which is a self-cleaning heat exchanger, which we can also supply, which is basically continuously cleaned and can be connected to any heat pump, which can have its advantages if somebody's got a specific application in mind in terms of flow return temperatures, delta T's, etc. Where a lot of the projects that have been installed so far in the UK, they are all pretty much abstracting from a sewer or a pumping station. So here's a schematic just to give you a feel from that. So you can see the sewer, which feeds under gravity to a pumping station. The wastewater is then pumped to a plant room where screening takes place. The wastewater goes through a heat exchanger and back to the sewer pretty much unchanged from when it came out of the sewer. And on the other side of that heat exchanger is a heat pump. And obviously the heat exchanger in question is a specialized bit of kit that is either self-cleaning or can be incorporated with cleaning in place technology to keep the surfaces of the plate heat exchanger or shell and tube, etc. clean, so the efficiency is kept high. The advantage with sewers is there's a lot more flow, so we're talking about delivering anywhere from 70% to 100% of the space heating domestic hot water demand of the end user, whatever that might be, a single building or a district heat network. In terms of kilowatts, due to the cooler temperature of the water, we're talking somewhere nearer 25 kilowatts per litre per second of wastewater. And obviously anything from 250 kilowatts to a number of megawatts can be achieved, and there are schemes being put in place in North America that are around the 10 megawatt mark, and schemes in Europe that are around the 20 megawatt mark. So this can be used for pretty big schemes as well as small schemes. Just to go into the types of sewer, we call it offline because all the equipment is out of the sewer in a plant room. So that's where the term offline comes from. A couple of configurations I'm going to go through now. One is where there's a simple pumping station, a buffer tank that can be used to recirculate the wastewater, which can be really important for periods of low flow and high temperatures. So we can use that wastewater more than once through the heat exchanger to achieve an overall higher delta T and actually get more heat out of the water per unit volume of water. But again, some form of cutter there or macerator screen before the heat exchanger, or in some cases a self-cleaning heat exchanger, which requires less upfront pre-treatment. And alternatively, more of the screening process can be underground, shown here in the pumping station, which means slightly less infrastructure in the plant room. If the plant room's constrained in terms of space, for example. So that's just another way it can be configured as well, where the screening happens earlier in the process in the underground structures. This is the Borders College site, which we own and operate. Just to give you a feel, on the right there is the macerator, and downstream of that is the screen, and on the left there you can see a carrier heat pump. So it's an 800 kilowatt scheme, 2 400 kilowatt heat pumps, been running about 6 years, delivering about a gigawatt hour a year for the college. Another scheme we were involved in was Equilibrium, a Scottish Water owned scheme up in Campbelltown in Argyll and Bute. There you can see it's a kind of triangular shaped car park, and on the far side of the car park is a small energy centre. And in there, we just put in the heat exchanger and screening equipment for the wastewater. And where it says HPs, in the existing plant room where they used to have an existing biomass boiler, that was replaced with a couple of water-to-water heat pumps instead. Here you can see a bird's eye view of the tanks going in the car park. So obviously once they were in it, it was all backfilled. The car park went back to its normal use. So we have there are manhole covers in the car park, so we can occasionally get in and out of those chambers to unblock pumps, clean pumps, service pumps, that kind of thing. So it's a pretty simple install in many ways. Another system is what we call an inline system, and that's where we actually put heat exchangers in the bottom of the sewer, which means there's much less infrastructure involved. So simply having two flow and return pipe from the heat exchanger in the sewer feeding the heat pump directly. And there are advantages, disadvantages of this. Obviously, there's a lot more involvement with the water company to get a system like that installed. None have been installed in the UK at the current time. It's something we're looking at to see if we can develop more schemes like this in the UK. But you know, literally hundreds have been done in mainland Europe and in particular Germany. So it is a viable technology that's been used a lot. I'm talking about 1 to 2 kilowatts per meter of sewer. I mean, that's a very rough rule of thumb, very much depends on the size of the sewer, flow rates, etc. But just to give you an idea, and schemes from anything from 20 kilowatts all the way to above a megawatt have been installed in Europe. There's just a picture of the technology there. You can see it's a stainless steel plate that's installed at the bottom of the sewer, connected together as modules with the flow and return pipes that feed the heat pump shown there at the bottom. Another opportunity for this kind of technology is actually to install equipment on sewage treatment works, or wastewater treatment works, as they're known. This technology can either be installed at the inlet, where the foul water is obviously still needing a lot of treatment, so there's more pre-treatment required before the heat exchanger, but the temperatures are higher and it might be the best location for the system, depending on where your end user or district heat network is. But it can also be installed at the outlet, which can have a lot of advantages in terms of far less pre-treatment for the heat exchange process, so cheaper in terms of capex, but lower temperatures as the water has gone through the process. And again, could be the best location or not, depending on where your heat user is located. Here's an example of a project we worked on a few years ago, again with Scottish Water, putting a system on a wastewater treatment works at Stirling. And that was used, that's a 500 kilowatt system used to provide the base load for a district heating network run by the local council. And you can see there again the macerator screening equipment and the heat exchanger on the right, and a nice picture there of our First Minister, just to show the kind of attention a project like that achieved. So yeah, they can be quite nice PR stories as well as everything else, these systems, when installed properly. A little bit more on this project, just to show the kind of simplicity, if you like, of the infrastructure. There's some open channels on the works and some pumps were installed with suction pipe work to abstract that water and simply pump it through above ground pipe work to the energy centre that I just showed you earlier. A pretty simple install. One important aspect that's worth raising for these projects is it's really important to get proper data before embarking on one of these projects to de-risk it. Wastewater flows are seasonal. Flows and temperatures do change during the year, as you can probably imagine. It's important to understand flow depths and velocities for sewer connection designs, and ideally, like we did on the Worthing project we mentioned earlier, we would collect up to a year's worth of data so we could really get a good understanding what happens in spring, summer, autumn and winter in terms of flows and temperatures, and make sure the system is designed correctly. We can do high-level assessments before putting monitoring equipment in, where we can speak to water companies and get model data, but we do find that can be a bit variable in its reliability. Here's just an example of the variation you can get within a day with sewer flows. So depending on how inundated the sewer is, obviously if the flows are way above what you need, you wouldn't really need any thermal storage or things like that. But if it is on the cusp of what you need to meet your peaks or baseload demand, we do have to allow for some either thermal storage or wastewater storage underground to cope with the fact you will get a bit of a dip in the morning, and then it obviously rises to a peak in the late morning to midday, and then continues to drop a little bit in the afternoon, where there's a second peak in the evening. So yeah, just to give you a feel for how the heat source varies during a day. That's obviously dry weather flow. If it's raining and there's a lot of rainwater in the sewer, that will be flattened out to a certain extent. Temperatures in the sewer, they do range geographically. Where we're based in Scotland, we definitely see cooler temperatures than we do down south in places like London. So here's just a bit of an example of some of the temperatures we've seen. The orange there are the minimum, blue are kind of average, and grey is kind of the maximum. So in the winter can be anything from about 7, in some cases up to 15 if it's foul only water. and on average about 10 during the winter, maybe a little bit higher, and then getting up to about 20 in the summer. So a decent temperature heat source. In terms of energy performance, it's all related really, as you would expect, to the heat pumps. Excuse me, the temperatures we're feeding them, in terms of the sewer temperatures, and the delta T, and obviously, as with any heat pump, the low temperature hot water temperatures and delta Ts, whether any simultaneous heating and cooling can be done using the same heat pump, and the heat pump refrigerant type, which can have an effect on its efficiency as well. And obviously wastewater pumping and screening, if there is a lot of pumping to do over a long distance and a high static lift, all that has to be taken into consideration for the parasitic electrical load. Here's just a kind of range of performances that have either come from real projects or calculations. So what we found at Borders College, which is in Scotland, which I've emphasised because it is a bit colder up there in terms of sewer temperatures, we've managed to achieve an SCOP, so a kind of annual COP, if you like, seasonal COP of 3.55, but that's over the whole 5 years, delivering 60-degree low temperature hot water. And obviously if you go down in low temperature hot water temperatures, the COP will increase, and if you go up, it'll decrease. Other things to consideration, like I've said, in terms of the overall performance or the seasonal performance factor for the system, pumping and screening, we also have to take that into consideration, and there are some quite big differences depending on what technology you opt for in terms of the heat exchange and screening equipment, which can have a large effect on that. Distance and height from the heat source, like I said, and whether it's fauna only, combined, or final effluent on a wastewater treatment works, which has very little pre-treatment requirements. Working with water companies, this is something we started in Scotland, where we wrote one of the first sewer connection agreements for this kind of project, working closely with Scottish Water and Scottish Water Horizons. There are some key aspects to it, so we didn't want to hide this aspect to this kind of technology, that this is a process you have to go through with a water company. They're all at various stages on the kind of development of this technology, if you like. Scotland's already there, and other water companies across the UK are at various stages, so it will vary place to place. But there are some technical issues that they will throw at you in terms of the effect on the sewer of reducing the temperature of wastewater. Fats, oils and greases gets raised as an issue, but there are lots of answers that we've developed over the years to back some of those concerns and give the water companies comfort that it's not going to have an adverse effect on their system. And obviously the commercial arrangements as well, in terms of connection fees in the form of a one-off fee, and whether they're going to want some kind of ongoing fee, whether that's an annual fee or a fee related to the amount of heat you generate as well. So it's really important not to forget this aspect of projects, and we've had some experience on that. Happy to share that with people. Applications, as you might expect, single large buildings, Borders College being an example that we've talked about quite a lot today, can be used for heating and cooling. It's important to mention cooling, we can dump heat into the sewer as well as extract it. District heat networks, as far as we're aware, there's about 2,000 in the UK and growing. Communal or community heat networks, about 20,000 of those. There's been a large project developed in southeast England to heat greenhouses. So we're talking about 30, I think it was about 30 megawatts there. So that was based on the final effluent and also we've had a number of inquiries for food and drink, leisure. Obviously the Aquilibrium project we talked about was a leisure centre, so heating swimming pools, etc. So there's lots of applications, and we're getting lots of inquiries for all of those kind of applications for this technology. So thanks very much for listening. So we can have a bit of a Q&A session. So Stuart, I don't know if we've had any questions at all. It'd be nice if we had some.
Yes, we have. We've had some great questions, and let's kick off with the first one, which was from Mark. And Mark has asked: in London sewers, there are obviously lots of waste materials, plastic, wet wipes, etc. How does the system perform under such environments, and are there any case studies for inner city sewer waste heat recovery? Wet wipes been a subject very dear to our hearts here.
Yes. Yeah, we've had a lot of experience with wet wipes. Believe it or not, even in Galashiels in Scotland, where we run our Borders college facility, we get plenty of wet wipes. And in the early years, I can honestly say it was the bane of our lives. So we went through a bit of a steep learning curve there. That was really the biggest problem, was the maceration of those. They tend to reweave together so they can form clumps, etc. But tweaking the system, changing the design slightly and altering a few things here and there, yeah, we've managed to get on top of that, which is really good. So I can safely say we've mastered that issue, so we certainly don't have any fear in terms of inner city wastewater or anything like that. So yeah, it is a very important consideration when looking at the technology. You're quite right to bring it up. It has been an issue, but it is easy to overcome as long as you know what you're doing, and you put the right equipment in place, the right configuration in place. You can handle it. It's not a problem.
Yeah, thanks, Joe. And I think it's also worth pointing out here that in the deployment of that technology in other parts of the world where they perhaps don't have the same cultural practices around seeing anything possible going into the sewer, and they haven't had those challenges, so that there are a number of UK specific, if you like, developments to the available tech that we have worked through, but because of the challenges we had at Borders.
Yeah.
And you know, you'll I'm sure all be aware of the efforts that the water companies make towards people putting appropriate things down into the soil and stopping wet wipes, but it does seem to be quite a stubborn practice. Next up, Phil has asked what would be the approximate capital cost of installing one of the systems as a retrofit into an existing sewer in the UK. Joe, do you want to start off with this one?
Yeah, I mean, we've obviously worked on a few projects now, and the prices can vary. It does very much depend on the very specific circumstances of the project, how far away you are from the sewer, how accessible it is, are there lots of services in the way, is it very deep, is it a fairly modern concrete sewer, is it an old Victorian sewer? So it does vary quite a lot, and so if you looked at putting it on a wastewater treatment works, it can be a lot cheaper, but I would say typically, and this is very typically, it can be anything from say £750 a kilowatt to kind of £1,250 a kilowatt to install, including the heat pumps and the energy centre, etc. But not the network, because obviously I don't know how big the network or the pipe work to connect to a specific building or whatever might be. So excluding that part, to install a system. And also I would put another caveat in, that's assuming a reasonable price for your DNO connection as well. So you're not having some major issue getting a power supply to the site. I think that's the kind of range we've seen to get one of these installed. Again, it also very much depends on the type of technology and the scale of the system as well, whether you're getting economies of scale or it's a very small system. So sorry, that's a bit of a broad range, but just to give you a feel, they're the kind of prices we've seen on projects that we've been involved with.
Yeah, it's it obviously the cost of the civil engineering works can vary dramatically from the depth of the sewer and obviously the location. We've talked already about inner city environments and central London. Obviously, the cost of that kind of work of that ilk within central London is greatly higher than it is elsewhere in the country. So there are a number of variable costs in and around the civil engineering, and then you might also look at what level of redundancy is planned to be built into the system as well. That kind of costing through exercise is our typical appointment for Recirc. Really, is to look at the viability and feasibility of a scheme through its cost, its predicted cost.
Definitely be comparable to ground source schemes, I think, in many circumstances.
Yeah. Phil also asked, are the systems suitable for district heat? I think we covered that one. So we'll move on quickly also to Neil's question, and is what is the anticipated running cost per kilowatt hour per kilowatt heat output? A lot of cost questions today, as pumps are shown in the diagram.
Yeah, I hate answering these questions because I'm either going to, put too low a value on it and then you're not going to believe me, or I'm going to put too high a value on it, and then you're going to say that's what it's always going to cost, and you're never going to look at it again. But again, it's a range. I mean, we operate the Borders facility. We do a lot of maintenance ourselves to keep the costs down. We use small local contractors to do any sort of electrical works or pump maintenance. All the kit is pretty standard, apart from the sort of heat exchange and screening equipment. But even that, it's got standard bearings, standard seals, standard motors. All the things that you need to actually look after are all pretty standard. So by far the highest cost is electricity, as you would expect to run the heat pumps. So obviously you can work that out for yourselves based on SCOPs and electricity prices. But in terms of a kind of pence per kilowatt hour to actually look after the system, again, economies of scale, depends where you are, how you do it, what technology you use. Again, it could be anywhere from sort of half a penny per kilowatt hour to 1.5 pence per kilowatt hour. And again, sorry to give such a broad range, but it does very much depend on scale and the type of system you use, unfortunately.
Thanks. So next question we've got from Paresh is, are current installations on private or public drainage networks? Well, I'll pick up on that one. And the current installations are all on the public network, but the configuration that Joe showed, one of the early configurations where we're capturing wastewater off the building and heat exchanging it before it reaches the sewer. In that instance, you would, of course, assuming that the land ownership falls within your boundary, you would, of course, be able to discharge that water separately without the necessary commercial agreement with the water authority. So, one of the advantages of that would be, of course, a faster development time for a scheme where it's possible to do that. So all the current schemes are on the public drainage network, but it's certainly possible to look at private if indeed you can catch the water off the network, off your development first.
Yeah, and save yourself a bit of potential ongoing cost as well that you might have to pay the water company.
Kieran has asked, what's the energy content in terms of specific heat capacity?
Well, depending on the temperature of the water, I mean, wastewater, although we talk about wipes and things like that, is generally 0.1% solids in it. So it is very dilute. So essentially it's the same as water. So, you know, if it's, you know, quite cool wastewater, it's around that kind of 4.2 kilojoules per kilogram per K. So yeah, it's about 4.2 to, you know, 4.185 kilojoules, that kind of range, you know, depending on what temperature it is. But the solids have very little effect on that because it's so dilute.
Okay, moving on. How would the system work in an old Victorian sewer, which is structurally different from modern sewers? And that's a tie-in connection question, I think, more than anything.
Yeah, I mean, in some ways it's trickier because obviously you need to assess the condition of the sewer, check that it hasn't sort of degraded over time, hasn't got lots of roots growing through it, that a lot of the mortar hasn't kind of washed away over time and things like that. And when actually installing a connection, you might want some kind of vibration monitoring to make sure you're not at risk of damaging the sewer as you're sort of digging and working around it. But to be honest, some of them are built better than some modern sewers, you know, built 150 years ago and still going strong, you know, in London. Concrete, the reason I sort of raise that is because obviously concrete might be reinforced, so there might be some reinforcement to deal with as you're trying to break into that sewer, which might need some specific coring, drilling equipment and techniques to do that. Whereas as Victorian sewers are normally sort of 3, 4 layers of brick, you normally know what you're dealing with that. And although brick is quite tough to core through, you know, it can be done. So it was more of a kind of general comment on just understanding what it is you're dealing with, you know, during that kind of design and costing process to make sure you kind of design and cost it properly.
Okay, next we've a comment here: surprised installations shown are not lagged or insulated in the plant rooms. Is that and perhaps just pick up, Joe, which point it's lagged from? It might not have been shown in the diagram.
Yeah, I mean, when we showed the Stirling project, there was a lot of external sort of plastic PE 100 pipe work, taking the water out of those kind of open channels to take it to the energy centre. And yeah, in my opinion, you know, you would have to look at that properly. It wasn't our decision on that particular project whether or not to lag it, but in some instances, because the water or the wastewater is not that much warmer than the ambient air temperature, you could argue, given the amount of time it's in that pipe, whether you're going to get any significant heat losses through it. And obviously it's fairly straightforward to do that calculation. But in terms of in borders on the wastewater kit, a lot of that pipe work wasn't lagged. Now it could potentially sweat because it's obviously going to be a lot colder than the temperature in that plant room, which can be quite warm given all the sort of pipe work in there and the heat pumps, etc., which give off a lot of heat. But in our experience, we don't find we have any issue with condensation or sweating of the pipe work. So we left it bare, you know, because obviously it's got a potential to soak up a tiny bit of the heat out of the room into the wastewater before it goes to the heat exchanger. But you're right, it's something to consider, that if you do think you're going to see a lot of condensation, you would lag it. But so far, touch wood, in 6 years, we've not had a problem.
Oh. Next question is: will organic Rankin cycle based heat recovery be feasible in industrial wastewater heat recovery?
Yeah, that's an interesting question. I don't know, is the honest answer. I have looked at organic Rankin cycle engines in the past, you know, when I was looking at other projects. I think they may be a thing of the future if they can get their efficiencies up. I don't know if wastewater is really going to be warm enough. I mean, it could be, and that's a very interesting question, and I'll probably go away and have a think about it and do a bit of research now you've asked it. But the honest answer is I don't know. But yeah, if there's an engine out there that has got a suitable, you know, refrigerant in it that could absorb enough heat from wastewater, so it actually kicked out as, you know, a decent amount of output, so it could pay for itself, because obviously they're quite expensive bits of kit. Why not? But I don't know of any examples of where it's done. Maybe an application for industrial effluents, which can be a lot hotter before they go to sewer.
Yeah, good. Next question is, what water authorities have you had discussions with or are aware of your systems? I'll pick up on this one. So I think it's probably fair to say that the technology of wastewater heat recovery is on the radar of all of the UK water authorities. And as Joe has alluded to earlier, that they are just at different points on the journey of accepting and deploying the tech. There are some regulatory considerations that they are looking at, but the companies at maybe the kind of more accepted, more advanced end of that scale are actively developing heads of terms with potential heat users, and are looking at a number of schemes to deploy it, not just on their own estate. At the other end of the scale, there are, I suppose, water authorities who are, for whom this technology sits still within maybe an innovation department, looking at whether it's possible to deploy it on their own estate first before they're prepared to offer a heat supply agreement. That said, they all have made commitments to net zero, and they are not without the challenges in getting there. And these kind of schemes, whether there's a commercial imperative, is something they explore still. But there certainly is a great PR imperative for it. Scottish Water, for example, report at board level the carbon saved at the Borders College project. And that was not a project that they funded in any way, but obviously it's very good news in terms of what the water authorities can report in an ecosystem where they are often in need of good news stories. So I don't think it's like I say, it's fair to say they're all looking at it, but you know, some are further ahead than others. We've talked to lots of them, and not all of them, but lots of them, and yeah, I think that's what I would say on that. Next up is, are the systems being considered for new sewers, as they are built, e.g. in London, the London Interceptor being built now?
Yeah, as far as I'm aware, they haven't done anything with that. It is, I mean, one of those technologies we showed there, that inline system where you can actually put heat exchangers at the bottom of the sewer, would be particularly well suited to that, because you could easily install that as you're building a new sewer. So that'd be a fairly simple installation. But yeah, not as far as I'm aware, it's pretty new in the UK. It's obviously something we're trying to change and encourage water companies to look at it and consider it. I think it is something that will come. But yeah, still at early days, I would say, for that kind of technology. I think we need to get some example projects in the ground, so water companies can see it happening, get some data, and get a little bit more comfortable with it, despite the fact that hundreds of systems have been put in mainland Europe. They always, you know, want to see it for themselves first. So a bit of a process to go through there.
Great. We've got a couple more really good questions, these two. And just a note for everybody who's asked about the certificate for attending. I think that's something you pick up with CIBSE, Home Counties North East, and or CIBSE Central. I'm sure they'll be issued them in the past for having done that. So the last two questions then. The first is this type of system similar to the seawater heat recovery systems used in data centers? If yes, is there any environmental restriction on the return temperature? For example, some data centers use those types of systems, must cool the water before it gets discharged back to sea. That's a great question, particularly I think in regard to looking at final effluent and possible environmental benefits of that. Joe, would you like to pick up on that?
Yeah. So obviously, if you're connecting to a sewer that is, you know, a reasonable distance before any treatment works, sewage treatment works, that's something they would probably be a lot less sensitive to, the water companies. We normally have had conversations with them about taking temperature out of the wastewater, and obviously discussions about their concerns, how that might affect the treatment process, because obviously a lower temperature will reduce biological activity, and it is a biological process, and that's more sensitive depending on what the treatment processes are. So if they're trying to remove nitrogen, for example, at the works, they might be a little bit more sensitive about reducing temperatures. Now, in terms of increasing temperatures, we haven't had many discussions about that, but my feeling is as long as you're not making too much of a difference, they could see that as actually a benefit to the treatment process, because it again, you know, could potentially increase that biological process. But one thing I think it's important to state in all of this is, in most instances, you're taking such a small fraction of what the treatment works is treating, that you're going to have a point something degree impact on the overall temperature of the works, which is actually going to be negligible. So there would have to be a very large number of schemes, or a large number of megawatts of scheme connected to these sewers before that would be an issue. The issue Stuart raises about the final effluent, that is a different issue, because then it's more of an ecological issue, that depending on the receiving water, so the river or whatever it might be, can even be a canal for some works. If it's a canal, it's going to be much less sensitive. They're probably not going to be too worried about the water being warmer. But where a river is particularly sensitive or got an ecosystem that could be affected by that, that could be an issue. So it'll be a very much case-by-case basis what the receiving water is, and what the ecology or the sensitivity of the ecology of that receiving water is. I hope that kind of answers it.
Well, the next question is from Tom, and it said, would it be possible for someone to install a scheme upstream and quote unquote steal your heat? Great question.
Yeah, and we get that one asked a lot, actually, because I think, yeah, that is a good question and a fair question. All we would say is that it's important to deal with that in your sewer connection agreement with the water company, and that's where we would deal with that, because clearly there's no point signing an agreement for connecting to a sewer for 25 years or longer if the water company can have another connection agreement 100 yards upstream of you, that's, you know, 100 megawatts or something like that, and going to rob all your heat. So that's where that needs to be dealt with. It's a fair question, it's a fair point. I mean, for us who are obviously in this business, a chance would be a fine thing. to come across that problem, as it's you know, there aren't many schemes around. It's very unlikely you're going to come across that situation at the moment. So get in there first is the first bit of advice, and then the second bit of advice is make sure there's a clause in that connection agreement that deals with that.
I think it's also fair to point out here that you know, where the technology deployed at that scale, that number of projects, there may well be projects that would be discharging heat into the network as well as abstracting heat, and there is work going on, research going on around how whole networks of sewers could act like essentially like 5th generation heat networks. And that's there could be a kind of balanced effect, if you like, of removing and dumping heat into the sewer. So quite an interesting area for it.
Yeah, definitely. If you've got someone who's got a big cooling demand upstream of you, then you're laughing, because you're actually going to get more heat. Yeah.
Excellent. Lastly, one more question here. We've got Rob, who asks, when the pipes are in the bottom of the sewer, how do you prevent fouling over time, and how do you clean them?
So this will be the inline system, I take it, where we put the heat exchangers. So you, first things first, you allow for the fouling, and you factor in the fouling in the heat exchange process. That's the first thing. And then, you know, you can have periodic cleaning, by which I mean, you know, a number of years between cleaning, as well as something you can consider. But primarily, they allow for a certain amount of fouling. So you allow for that in the design in the first instance. So you allow for a reduction of roughly, I don't know, 50%, I think it is, heat exchange for that fouling process. And also you would look at the flow rates and velocities in that sewer as well, because obviously for slower, less, you know, turbulent, if you like, flows, that's going to be more of a consideration where you've got a sewer that's got a good healthy flow all the time, and therefore have a self-cleaning, what we call a self-cleaning velocity to the water. So yeah, again, important to get that data, look at the flows, depths, velocities, when doing the kind of feasibility and design to account for all that. But yeah, primarily it's allowed for in the design, but in some instances there might have to be periodic cleaning if there isn't sufficient velocity in the wastewater.
Great. So it looks like the end of the questions from everyone. I do hope everybody found that informative and helpful, and you know, I hope it's kind of firing off lots of questions in your heads around projects that you might be working on. We'd be very happy to take a no obligation high level view at anything that you wanted to bring forward to us. Our contact details are here. If you enjoyed the presentation, please do contact with us and join and follow us on LinkedIn. And thanks very much again for your time. We'd love to hear your comments back. So yeah, if you've enjoyed it, please let us know, and we look forward to hearing from you all.
Yeah, thanks very much for coming, and yeah, thanks very much. So yeah, goodbye.
Thanks for your time, everyone.